Okay, and so we will now begin today's class. So welcome back, everybody. Welcome back to Global Kids Connect Mathematics. And for today's class, we will be covering the topic of linear equations. So I think today we can jump straight into it. And so our topic today, linear equations. So the first topic and the first concept we'll be learning today is slope and intercepts. And the definition of slopes and intercepts is that a linear equation represents a straight line on the graph, typically written in the form of y equals mx plus b, where m is the slope, which is the steepness of the line, and b is the y-intercept. And the slope formula can be given by when you're given 2 points of x1, y1, and x2, y2. And the slope can be written with the equation m equals y2 minus y1 over x2 minus x1. So just to get a feel for what a graph would be. So if we have a xy plane here, the horizontal being x and the vertical being y, with the origin in the middle. If we have a linear line, which means a straight line that goes through, and it has the equation of y equals mx plus b, then the slope or the change in x, so it will be x2 minus x1 under the change in y2, y minus 1, is equal to the slope, which is m, and then this b within the equation represents the y-intercept here. So it's just very simple and something to memorize for the SAT Digital Mathematics. And a key skill for questions that are related to slope and intercepts is that you should have to find the slope and y-intercept of a linear equation by rewriting it in a slope-intercept form. So we will now take a look into an example of this. If you need time to write down on your notes, then please feel free to tell me, and then I'll give you some time. Okay, we will be moving on, and just so you know, if you weren't able to take down notes within the class time, I will be sending out the class presentations through emails to each of you, so no need to worry about that. So let's take a look into an example question. So first problem, very simple. What is the y-intercept of the equation 4x minus 2y equals 8? So we have a linear equation, meaning that the uh, power of x is only 1, and we are given in a general equation term, then we can rewrite this so that we can isolate the y variable onto one side and then push everything else, such as the x variable and the constants, to the right so that we can get a much more usable equation. So what I mean by that is if we leave the minus 2y on the left, but then move the 4x to the right, we get negative 4x plus 8. And now we have to isolate the y, and so we will divide by negative 2. So to get y equals negative 4 divided by negative 2, the negatives will cancel out and it will be 2. And then we will divide by negative 2, it will be negative 4. And so now we have a uh, expression for a linear equation that we can use to analyze a linear graph and a linear curve. And so what this means is that if we graph this linear line, then we have the y-intercept of negative 4. So we put negative 4, let's say it's around here. Then it will pass through this y-intercept with a slope of 2. And so if it's positive, the line will point upwards. And the greater the magnitude of the slope, the steeper it is. And so the question itself only asks for what is the y-intercept. And so, very simple, we can say that the y-intercept is -4. And we can also draw a graph to prove this and understand it a bit better. Any questions for this one?
No, sir.
Okay, then I will be moving on. And yeah, just the same solution, but written. And then a tip for this kind of question is that to always isolate the y variable in order to find the y-intercept much easier. Because the original equation form we are given, there's nothing much we can get away from and nothing much that we can analyze and understand about the y-intercepts or anything else. And therefore, you should always isolate the y variable. Moving on, we will move on to a different concept that builds on to this is parallel and perpendicular lines. And so, first of all, parallel lines are two lines are parallel if they have the same slope. So what this means is that parallel means they have the same slope, two lines. So let's say this could be y equals 2x plus 3, whereas the other slope is 2x plus 1. You can see if the slopes are the same, they never touch and they move parallel, like I said, all throughout the domains. And so the opposite of parallel lines is perpendicular lines, which are two lines are perpendicular if their slopes are negative reciprocals, which means that if a slope of one line, let's say, let's erase this. If they are perpendicular, it means that the two lines have slopes that are opposite and they form a 90 degrees between the two lines. So how do we know if two lines and two slopes are perpendicular? We use the negative reciprocal rule, which is stated here. So if we say that the first graph had a slope of n1, x, and the second graph had a slope of y equals n2, then we can say that, yes, when m1 times 1 over m2 are multiplied, then they must equal -1. One moment. So, actually, there might be a slight error. One moment. It is not the 1 over m2, however, it is just m2. Yeah, my mistake on that one. So when multiply the two slopes, m1 and m2, and if there are -1, the product that they can be said to be perpendicular. And so we can see, for example, if one slope is 2 over 3 and the other slope is -3 over 2, if we multiply these two, we can cancel out the 3's and cancel out the 2's so as to get -1. Therefore, we know if the slopes of two lines, if one of them are 2 over 3 and the other one is -3 over 2, then they will be perpendicular. Key skills regarding problems related to this concept is to determine the slope of a line that is parallel or perpendicular to a given line. So most questions related to parallel and perpendicular lines will always, most of the time, be related to slopes and will ask for you to find the slope, whether that be the final answer or in between your solving. So we can move on to a example question. So what is the slope of a line perpendicular to the line defined by 2x plus 3y equals 6? So the question asks for the slope of a line that is perpendicular to which line? This line. So in order to find the slope of the perpendicular line, we have to find the slope of this line first. So we'll do that now. So if we have a line that is expressed in 2x plus 3y equals 6, then like we did for linear equations, we can isolate the y variable. So we can do that by leaving the 3y on the left side while moving everything else to the right. So we get negative 2x plus 6. And then we can divide by 3 to leave just y on the left side, and then get a slope of negative 2 over 3x plus 2. Now that we know the usable and useful expression for this linear line, we can now find the slope of the other line that is perpendicular to this one. And like I said, uh, the rule for two slopes being perpendicular is when they are multiplied, they must equal -1. So we can use this to say, because we know the slope of the first line is -2 over 3, we put -2 over 3 here, and then put m2 as the variable and equal to -1. And so we can divide each side by -2 over 3 so that we can get m2 equals -1 times -3 over 2 because we divided. Negatives will cancel out and it will equal to 3 over 2. And therefore, our final answer will be 3 over 2. Any questions regarding this one?
No, sir, not me.
Okay, great. Here are the written solutions. You will have access to this once I give you the PPT after the class. So no worries. And a tip for perpendicular questions is for perpendicular slopes, flip the fraction and change the sign. So what does this mean? So you remember just now, we found that the slope of the first line, this one, was -2 over 3, right? Sometimes uh, using the equation m1 times m2 equals -1 can be a bit confusing. So we can change this rule so that we can say that m2 equals -1 over m1. So it's saying the same thing, but a different format. So if we know that m1 is equal to -2 over 3, then in order to find m2, we just flip the fraction so that instead of 2 over 3, we get 3 over 2, and then again reverse the signs. So instead of negative, we will have positive. And so if you want to save time, which is very important within the digital SAT math, then I do recommend just memorizing flip the fraction and change the sign so as to get the perpendicular slope. Any questions related to this?
Not for me, sir. No.
Okay, if not, then we will move on. We have another practice question, this one related to parallel lines. So the linear equation y equals 1 over bx minus 2 is parallel to the linear equation -3y, -4x equals 6 when drawn on the xy plane. What is the value of b? So we know that these two lines are now parallel, and therefore we don't know the slope of the first linear equation because it has a variable b. Whereas the second equation, we have the full equation. And so we will use the second equation to find the slope. And because they're parallel, the other equation will also have the same slope. So first of all, uh, like we did until now, we will re-express this equation so as to isolate the y. So it's simple enough, the same thing. And then isolate the y so as to get -4 over 3x minus 2. Now that we have this equation, we know that the slope of the second equation is -3 over 4. Excuse me, -4 over 3. Now, if we know this, then we can say that the first linear equation, which was y equals 1 over bx minus 2, will have the same slope. And therefore, we can say that the slope of -4 over 3 is equal to the slope of 1 over b. So now we just have to find b. So we will multiply each side with b so as to get excuse me. Yes, that is correct. We will get a b value of -3 over 4. And therefore, we found the answer to the question because it asked for the value of b, and here it is. So only thing to remember regarding parallel lines is that if two lines are parallel, then that means they have the same slope. And therefore, for this case, for this question, we found the slope of one equation and then set that equal to the slope of the other equation so as to find the variable that we needed. Any questions?
No.
Okay, if not, then we will move
No,
on.
sir.
Same thing here. And then for the tip, always compare slopes directly after converting the equations. So what this means is that uh, we had the second equation in a form that is not useful to us. And so you should always convert it to this form of a linear line, of this form of the expression, so that we can directly compare what the slopes are. So that's the only thing you have to remember for these kind of questions. And we will now move on. So the final concept for today's class is systems of linear equations. So this is similar to the systems of equations that we did uh, during our last class, but it builds up on that concept. So the simple definition is a system of two linear equations can have one solution, which means a intersecting line, no solution, which means a parallel lines with different y-intercepts, or infinitely many solutions, which means the same line. So this might be a bit confusing, but we'll go through each one. So we can say in the case when two linear equations have one solution, also known as intersecting lines, we have a xy graph here with a origin, x and y. If one equation, just for example, has a linear line that goes like this, and another line that goes in a different direction, absolutely separate from the first equation, we can see that it intercepts at one point, a singular point, which, and this point where the x and y values, x1 and y1, uh, are both answers, solutions to both equations and both lines. We call that a solution of two linear equations. So we see that when there's only one solution or a single point, then it is a intersecting line. Moving on, if we have no solutions, this means that there are parallel lines with different y-intercepts. So we can draw this again. I'll draw it here. We have one line going here and another parallel line, but it's have a different y-intercept. First one has a positive, the second one has a negative one. We can see that there's no points at when they touch each other, and which means that there are no solutions and no intercepts. And so when we are given two equations, let's say y equals 2x plus 3 and y equals 2x minus 3, we can see that the y-intercepts are different. However, the slopes are same, which is exactly this situation. And in this situation, we say when asked for a solution, we say that there is no solution because there are no points at which the two lines intercept each other. Now, the opposite of this is when two lines are the same line. So we may be given a equation where it says y equals 2x plus 3, and another line which says 2y equals 4x plus 6. But these two lines are actually the same line. It's just that they are multiplied by 2. And we can simplify this second equation by dividing everything by 2 so as to get the same line. So what happens when we are asked to find the solution of two lines that are the same line? Well, they because they're the same line, they have infinitely many intercepts. Uh, so if there's infinite number of intercepts and infinite number of points at which they touch, then it means there are quote unquote an infinite number of solutions. And so you only have to memorize these three key points. And then just for being easy to remember, no solutions means slopes are equal, but y-intercepts differ. And conditions for an infinite solution is that both slopes and y-intercepts are the same. And key skills for these kind of question is to analyze a system to determine the number of solutions. So nothing really creative or any like stuff like that, but just to make sure to analyze the equations thoroughly and make no mistakes and stuff like that. Any questions before we move on to our practice questions?
No, sir, not at all.
Okay, then we'll move on. So our question asks for what is the solution to the system of equations x plus 2y equals 7 and 2x plus 4y equals 10. So right now the expressions of the equations are not useful, so we'll change them like we said. So first equation, we have x plus 2y equals 7. Then we will isolate the y, divide by 2, so as to get this equation. And then we do the same thing for the other line. So if we have 2x plus 4y equals 10, then we get 4y equals negative 2x plus 10. And then again, divide by 4 so as to isolate the y. We get negative 1 over 2x plus 5 over 2. Now that we have expressed the two equations in a way that we can analyze slopes and the intercepts, first thing that we can see is that the slopes of the two equations are the same, which means that they are parallel. Now, if two equations are parallel, there's two possibilities. Either there are no solutions or there are infinitely many solutions. And that depends on what the values of the y-intercept are. And so, one moment. Yes, and so because we see that the y-intercepts are different, one being 7 over 2, the other being 5 over 2, we can say that because the slopes are same, but the intercepts are different, they are parallel and have no intercepts. And if they are parallel and have no intercepts, then it means that there are no solutions. You can also graph these two equations to analyze them better. So if we have x and y here, then we can say if the intercept here is 7 over 2, then we will have a slope that goes like here. And then if we have intercept of 5 over 2, same thing, because they are parallel and have the same slope, they have, no matter how far you look, how far you zoom out, there will be 0 intercepts and 0 solutions. Any questions for this one? No? Then okay.
No.
No, sir.
Yep. Same thing here. And then for tips for such questions is that if the slopes match but the y-intercepts don't, the system has no solution. Okay. We will now move on. Our second question is, what is the value for k given that the system of equations kx plus 3y equals 1 and 3x plus ky equals 2 has no solutions? So this question is a bit different because it gives us two expressions of linear equations that have an extra variable of k. So we can't directly solve to find the slopes or the intercepts because we don't know. However, it does tell us that there are no solutions. So once again, if there are no solutions, it means the slopes are parallel and the y-intercepts are different. So knowing this, we can first start off by re-expressing the equations like we have done until now. So we'll do that now. So kx, the first equation, plus 3y equals 1. Negative kx plus 1. And then we'll have y equals negative k over 3, x plus 1 over 3. And then we do the same for the second equation. We have 3x plus ky equals 2. Then isolate the ky. And then y equals negative 3 over k x plus 2 over k. Now, we have two expressions here. And first of all, we can say that because we know the two lines have to be parallel, then their slopes will have to equal the same. So we take the slopes of the two equations, then we say that they are equal. If we know this, then we can solve to find k. Uh, for simplicity, we can say we multiply each side by 3k. And so if we multiply each side by 3k, to make it simpler for us, then we get on the left side negative k squared equals, and on the right side we'll have negative 9. And because they're both negative, we can get rid of the negative sign so that they're both positive. And if we know that k squared here is equal to 9, then k has a value of either 3 or negative 3. So because we have two values for the variable k, we can check uh, whether these two are actually real true values that can be a true answer for our situation. And so, one moment, let's get some extra space. So we know that k can be either 3 or negative 3. So let's say first situation when k is equal to 3, we'll plug in to these two equations that we have to compare. So first equation will be y equals, if we plug in 3, it will be negative x plus 1 over 3. And then for the second equation, we will have y equals negative x plus 2 over 3. And so we'll check if this meets our conditions of there being no solution. So yes, the slopes are same, so they are parallel, and the y-intercepts are different. And so k equals 3 is an answer. We'll now check whether k equals negative 3 is also an answer. So for k equals negative 3, once again, plug into the equations we have. And first equation, we will get a slope of positive 1 and a y-intercept of 1 over 3. Second equation, we have a slope, again, of positive 1, but the y-intercept is different with negative 2 over 3. And therefore, because in both situations, when k is equal to 3 and negative 3, uh, all the equations satisfy the conditions stated here. Then we can say that both k equals 3 and k equals negative 3 are values of k. You won't have to write within the digital SAT. It will be a multiple choice. So just choose whichever k value is either 3 or negative 3. Uh, Most of the time, when you find multiple answers to a certain variable, like for us, we got k equals to both positive and negative 3, the multiple choice will only include one of the two answers. And so, in that scenario, just choose the answer that has either one of these values. Any questions regarding this one? Nope. If not, okay, no, if not, then I will move on. So we have a solution here. talking about the same thing, and we can say that both -3 and 3 can be values of k. For tips regarding these kind of questions is to solve for the parameter by setting slopes equal and checking the y-intercepts. So what this means is that we had a parameter of the slopes being parallel, the same, and the y-intercepts being different. And so we will check the slopes to be equal, set them to be equal, and then find values that satisfy that parameter. And then we can check the y-intercepts, whether they are different, in order to prove that the two equations have no solution. Okay, we'll move on now. So the last question of today is a challenge question. So this one might take a bit of time, but we'll go through it slowly. So let's read through it first. A system of three linear equations is given by 2x plus 3y equals 5, 4x plus ky equals 10, as well as mx minus 6y equals -3. So this time, instead of two equations, we have three equations, where k and m are constants, and the system has exactly one solution. And the line represented by 2x plus 3 equals 5 is perpendicular to the line represented by mx minus 6y equals -3. What is the value of k plus m? So a lot of information that we have to analyze, but if we do it step by step, you'll be able to understand it very clearly. So first of all, most important thing, we have three equations for this one. So automatically it becomes a bit more harder than our other practice questions. It tells us that k and m are constants, so there will be numerical values. And the second most important thing is that the system has exactly one solution. So, like we covered before, when there is only one solution, it means that the lines meet,
Intersecting lines.
yes, the intersecting lines only intersect at a single point. So we had an example of two lines, but if there are three lines, how would that happen? If the third line, maybe if it's different from the other two, will go past the same intersection point. So we'll use this information and this knowledge in order to solve for K and M. So the first thing we have to do is, actually, before we move on, there's more information. Uh, and the line represented by this equation is perpendicular to the line represented by this equation. So this means that these two equations are perpendicular. And so the first thing we can do is, because the original expressions that we are given, two of the equations have variables. So with only one equation, it's hard to do anything. And so we utilize the information the question gives us. The first thing we'll use is if these two lines being perpendicular. So we will change the word. There's a slight typo. There should be a y here, actually. Yeah. And so we will say that if these two equations are perpendicular, then their slopes must be when they're multiplied, it should equal -1. And therefore, we'll try to prove that by saying we have the equation 2x plus 3y equals 5. Then we isolate the y, and then divide by 3. And so, and then we do the same for the second equation, which was mx minus 6y equals -3. The same thing, and then y equals m over 6x plus 1 over 2. So if we know that the two lines are perpendicular, then, like we said, n1 times m2 will equal -1. And so we'll try that with -2 over 3 times m over 6 equaling -1. So we can simplify this multiplication by saying we can divide by 2, so we got 3 here, 1 on top. So negative m over 9 should equal negative 1. And therefore, we can say that m, the variable m, has a value of 9. So we found the first part of our answer, the value of m. And using this value of m, we can now find the value of k. So how do we do that? Well, let me erase this first. The most important thing, we now know that m is equal to 9. So now the only information that we can use is that the three equations have one solution. And so, how do we solve this? Well, we can do the same for, actually, let's go back. We can utilize our previous uh, solution. Bring it back, a bit more back, a bit more. Takes a while. We can see, yeah. So from here, we can utilize the re-expressed equations as well for our second part of the solution. And so, oh, nope, that is not the tool that we need. Let's rewrite it. And so the second equation with the variable m, we can now replace the m with a value of 9. So that we can get the equation of y equals, if we put 9 over 6, it will be 3 over 2 x plus 1 over 2. And once again, we'll put it in the corner here, m equals 9. And now we have to find k. So we now know two equations, and we also have the third equation, which included the variable k. And if we simplify, if we re-express that very quickly, I'll skip the steps, but then it will be negative 4 over kx plus 10 over k. So we have now three expressions. So how do we use these to find one solution? Well, if there's only one solution, then that means there's one interception point. And so we can use equation 1 and equation 2 to find the point at which the two graphs and the three graphs intercept. And so how do we do that? Well, we can see that both equations are set so that the left side is y and is equal to an expression. And so we will set these two parts equal to each other. If we do that, then we get 3 over 2x plus 1 over 2 is equal to negative 2 over 3x plus 5 over 3. And so if we know this, then that 3 is a bit weird. If we know this, then we can now solve for the value of x. So in order to simplify, we'll multiply each side by 6 because that's a common multiple. If we do that, the entire thing multiplied by 6, we get on the left side 9x plus 3 is equal to negative 4x plus 10. And then we can move around so that we can get 13x is equal to 7. And so our x value of the intercepting point will be 7 over 13. Now, we know x, and we can now find y as well. So we can plug in the x value into either equation of equation 1 or equation 2. Doesn't really matter, you get the same answer. If we do that, let's say we plug it in into equation 1, then we will get y equals 3 over 2 times 7 over 13, the x value we found, and plus that with 1 over 2. If we do this, then we get nothing simplifies, but we can multiply, so we can get
21 by
22,
26 plus half.
21, yes, and then 1 over 2. And 1 over 2, we can actually re-express that by multiplying 13 to both the numerator and denominator, so as to get a common denominator, and then we add together for a 26 on the bottom and a 34 on top. And we can simplify that to get 17 over 13. So we now know that y value is 17 over 13. I'll clean this up so it's easier to look at. 17 over 13. Now we know that the point at which equation 1 and 2 intercept is 7 over 13, comma 17 over 13. So with this information, we can plug these values, the x and y values, into our equation 3 so that we can solve for variable k. So we will do that now. If we plug in these x and y values in the equation 3, we will get y is 17 over 13. That is equal to negative 4k times 7 over 13 plus 10 over k. It's very hard to look at because it's very the variables are on the denominator and everything is confusing. However, we can multiply each side. We have 13 on the left side, and we also have 13 and k's on the denominators for each side. And so we'll multiply the common multiple, which in this case will be 13k. If we multiply 13k, like here, I'll get rid of this for now. This will be equal to
DK.
17k equals negative 28 plus 130. You can prove this
Negative.
by saying that if we multiply this first, then the 13s will cancel out, and we'll have 17 and k left, so we get 17k. And then for the second part, for here, we can multiply 13 cancels out as well as k, and so we will get a negative 4 times 7, which is 28. Oh, sorry. And then for our last part, if we multiply it to this, then only the k cancels out, so it's 10 times 13, so we get 130. Knowing this, we can set this equal. We can add these up to get 102, and therefore k will equal to 102 divided by 17. You can use the decimals calculator if for difficult divisions and multiplications like this, and the answer you will get is 6. And so we found the k value, but we have to make sure that we can double check to make sure this k value is actually making sure that the three equations only meet at one point. So we will do that now. And so we have our k value of 6. We have k value of 6, then we can plug it into this equation so that we can get 4 over k becomes 4 over 6, or 2 over 3. We replace that with 2 over 3x. And then 10 over k will become 10 over 6, which is same as 5 over 3. Now, interesting thing you can see that equation 2 and 3 are actually the same equation within this context. So you may be thinking, does that work? Is that still fine? And the answer is yes.
It's the same line.
Yeah, because it is the same line, we can technically say that uh, they are not separate, but so in the context of this question, there is only one solution because there is one intersection point between all three. And so we can graph this so that we can get 1 over 2 at the slope like this for equation 1. And then above that, we'll have 5 over 3 with a slope of negative. I like this for equation 2, which is same as equation 3. So technically, we will have a two equation question instead of three. And so we can think of it as just equation 1, equation 2, and one single intersection point. Yeah. Does anybody have any questions regarding this one?
No, sir, not any.
Nope. If not, then this will be our last question for today and for today's topic. So great job, everybody. We went through basically all of linear equations. Yes, and so uh, that'll be it for today's class. Once again, thank you everybody so much for joining for today. If you have any questions, please feel free to reach out through email. And after the class ends, we will send out the PPT to you so that you can use it as study material until our next class. So if you have any questions, you can stay and ask me. If not, you are free to leave. Thank you.
Okay, I do have a question.
Yes.
How do you solve such a question using the Desmos calculator?
Okay. So that's a great question, actually. So let's take a look at one of our example questions. So yes.
I like the question I'm talking about is the last question,
Uh,
the one
okay.
finished right now.
Yes. So our last challenge question you can solve by so our previous approach regarding this question was doing it algebraically, so using equations step by step comparing. However, utilizing the Desmos calculator might be useful as so if we know the entire expression for the line, then we can plug that expression directly into Desmos and it will graph the graph for us. However, we can't do that right away because the other two equations have variables that we don't know the values of, such as k and m. So, uh, in the first part, we will have to do the same as we did just now for the perpendicular lines in order to find the value of m. And then once we know that the value of m, like we got, was equal to 9, then you can actually utilize the decimals calculator in order, and then so if the decimals, as far as I remember, will come up like this with areas where you can write down your equations. And so if you write down the first equation, 2x plus 3y equals 5, the calculator will graph you a graph similar to roughly this. And then because we found value of m through our algebra, we can plug that value of m directly into this equation without re-expressing it, and then put that right into Desmos calculator. So that we will have a equation of 9x minus 6y equals -3. And once this happens, we will actually have a second graph that comes up like this. The exact graphs might be different from what I'm saying, but then there will be a singular interception point that you'll be able to see. And if you hover your either computer mouse or trackpad over this point, then Desmos will there will be a point that pops up showing a x value and a y value. So you can use this x value and y value actually in order to find the k value like we did for our previous solution. And so this is actually a very good point to make because these kind of questions could take a long amount of time. And then if you're short on time during the test, then obviously it's a lot of work and a lot of math to go through it. However, if we can use the decimals calculator to find the interception point, then it makes our lives much easier. So if we find the interception point, then we can plug it in directly into the second equation to also get the k value. So, in to sum up your question, yes, you can utilize the Desmos calculator. In the context of this specific challenge question, you can't use it right away, but then once you know two equations, the full expressions, then you can plug it into the calculator, find the interception point, and then finally use that interception point and plug it in to the remaining equation that has a variable. Find the variable, and then you can find k plus m, which was in our case was 9 plus 6, which was 15. Was that explanation good?
Yeah, I had the same idea. I just wanted to confirm.
Ah,
Have
yeah. really, that was actually a very great idea. I think so. A common trend within the digital SAT math is that if you can use the calculator like the decimals, or if you have one of your own, then it can save you a lot of time. So obviously, if you are kind of struggling with time management within the SAT mathematics, which is a common problem between amongst all students, then yes, try to think of creative ways or just uh, in any way try to incorporate using the calculator to shorten your question solving time. Any other questions?
No, not really. Well, thank you. Bye.
Yeah. Okay, yeah. Anyways, thank you so much. You can leave. And I will see you our next class on Tuesday, next week, Tuesday.